Angelica M. Sinoy.
And I am Christina Adaro.
And now we are going to discuss about integrals involving
Transcendental functions.
Now let's start.
So, first and foremost, before we proceed on our discussion, we must know what is an integral. In mathematics, an integral assigns number to functions in a way that can describe displacement, area, volume, and other concepts. Second is, what is a transcendental function? A transcendental function or transcends algebra is that it cannot be expressed in the form of a finite sequence of the algebraic equation, which is addition, multiplication, and root extraction. And lastly but not the least, the example of transcendental functions include the exponential functions, the logarithm, and the trigonometric functions.
To start with this lesson, there are derivative integrals which has corresponding antiderivative integrals of transcendental functions. Always remember that transcendental literally means non-algebraic. In other words, these functions are beyond algebraic limits, which means that transcendental functions are also cannot be expressed by algebraic operations.
So let's now find the antiderivative of the following transcendental functions. So, example number 1. The antiderivative of 4 to the power of x. This function is a general exponential function, and we're gonna apply this rule to find the antiderivative. This rule is the general antiderivative for the exponential function. So the rule says that the antiderivative of a to the x is itself multiplied by 1 and divided by ln of a plus c. So let's go back to the example. According to the rule, it is equal to itself multiplied by 1 L of n with its base, which is 4 plus c. So let's go to the next example. Example number 2. The antiderivative of 7 to the negative x. So we will apply the same rule. But in this example, we have a negative x, so we cannot apply this rule yet. We need to somehow turn that into a positive variable through substitution. So let u be equal to negative x. And that would imply that the derivative of du is equal to negative dx. So in order for us to make a substitution, we will use to get rid of the negative in the dx. So now we can make a substitution, and we will now replace this dx with du so that will be replaced by a negative du, and now the negative x will be replaced by u. So this is now the new example. So with this, we can now apply the rule. So the antiderivative of this example, according to the rule, is itself multiplied by 1 over ln and its base, which is 7 plus c. So for our last step, we will need to replace what u is, and u is equal to negative x. So we will place u with negative x and plus c. So it will now be the antiderivative of negative x multiplied by 1 over ln with the base, which is 7 plus c. And that would be all. I hope you enjoy and learn something in this discussion. Thank you.
Good day everyone, thank you for listening and watching this video.
I hope you learned something from our discussion.
For more information, just click the link below.
Bye and have a good day, everyone.